Triangles. You see them just about everywhere, common to the naked eye, but how much of them don't you see? Well, first off, triangles are part of trigonometry, which is a subcategory of mathematics. You know, pre-algebra, algebra, geometry, algebra 2, pre-calculus, calculus, and the list just goes on and on and on. Now, trigonometry is focused around using mathematical relationships and trigonometric functions to solve partial geometric equations. What's the translation? Well, triangles are used in everything. It's as simple as that. Now, contrary to popular belief, trigonometry is not an attempt by teachers to crash a student's GPA. Although for some of us,
it's done a really good job of that. Am I right? Up top.
So what makes trigonometry special compared to other math categories? Well, check your pocket. You probably have a little metal device in there which sends out anywhere from 4 to 7 million, that's 6 zeros, sine waves per second. Or maybe, did you happen to ride in a vehicle today? In order for the vehicle to even move, the travel distance of the pistons within the engine, along with the rotation of the drive shaft, need to be calculated. Heck, the clothes you're wearing right now require the use of trigonometric mathematics to calculate the dimensions and any style associated with the apparel. Yeah, you're living in a trigonometric world. Try saying that 5 times fast.
Okay. You get it.
Trigonometry is a large factor of modern life as we know it. But just how much does it impact us? Well, let's solve some trig to find out. If you recall, the unit circle provides a basis for us to work off for trig, so why not use it? A great example of basic or fundamental trig in the world would be a, can you guess it? A driveway! No? Whatever. They tend to range anywhere from 18 to 24 feet for the average home, so let's use the number 20 for the radius. Now, each state has different laws regarding the minimum slope or angle from the main road the driveway must be tilted or angled. So let's use an average number, let's say 15 degrees, and we'll substitute that in for theta. We know that the angle of 15 degrees does not exist on the unit circle whatsoever. But what if we were to say use 30 degrees and then a half angle formula to solve for both sine and cosine? We could then figure out where our driveway would intersect on the unit circle if the radius was 1. First, let's solve for cosine of 15 degrees. Cosine of 15 degrees equals cosine of 30 degrees divided by 2. Once you plug that into the half angle formula, you get the square root of 1 plus cosine of 30 degrees divided by 2. Once you solve that, you get the square root of 2 over 2 plus the square root of 3 over 2 all over 2. Where'd the 2 over 2 come from? I just took the 1 from the previous equation and changed it to a 2 over 2. That way it could be more easily added to the square root of 3 over 2. Once you solve that equation, you are given a square root of 2 plus the square root of 3 all over 2, but then it's multiplied by 1 over 2. Where'd the 1 over 2 come from? Well, the denominator of 2 in the previous equation, I just switched it to a 1/2. That way it could be more easily implemented into this equation. After you solve that, you get a square root of 2 plus the square root of 3 all over 2. But wait, 2 times 2 is 4. In the previous equation, we had the square root symbol in both the numerator and the denominator of the fraction. So, on the denominator, we had the square root of 4, because 2 times 2 is 4. Well, what's the square root of 4? 2. So we don't need the square root symbol anymore, because we already solved for it. Now, on the numerator, we're not that lucky. We will still have to keep the square root of 2 plus the square root of 3 all over 2. We then use the half angle formula for sine to get the y value on the unit circle. If you wanted to be fancy, you could mess around and plug these two radical equations into the Pythagorean theorem and solve for r, but we understand that r is 1, so why do the extra work? Now we have the information required to understand the x and y distance for the driveway if it was 1 foot long. But our driveway is 20 feet long, so multiply both the x and the y by 20. Now we have the data that x is about 19.32 feet and y is about 5.18 feet. Just to make sure that it was solved correctly, plug it back in the Pythagorean theorem and make sure that x squared plus y squared equals r squared. That's about 400.09 equals about 400. Yes, there is variance between it. I rounded it up. I'm too lazy to put in 30-ish numbers after the decimal point.
Yeah. Calculating the dimensions for a driveway isn't your thing. Got it.
So what about how your cell phone transmits all of your text messages, and for some of you, exclusively Snapchat, through sine waves? Yeah, that extremely heartfelt message you sent to your boyfriend about how he is the only one for you is nothing more than a sine wave. Yeah, that's why it's so easy to steal data online. It's just a sine wave in a pattern. Well, what does that mean? Well, your cell phone has two main electrical components inside of it, a transmitter and an antenna, that output sine waves of multiple combinations of variations of amplitude and of frequency. Remember, amplitude is how high and how low points are on a sine wave, and frequency is the number of waves in a per unit of time, usually seconds. Whatever phone company you're subscribed to has different ways of implementing patterns and templates for use of these variations, and some even go as far as to modulate a carrier wave. What does that mean? Well, a modulated carrier wave is just a really fancy way of saying that they're putting a sine wave on top of a sine wave. So, you want to try calculating that?
Because I don't.
In a nutshell, trigonometry is such an essential part of our lives today that without it, everything we take for granted wouldn't be possible.